Okay, wait for it. Oh, smashed apple. Okay, so why do these magnets come together? Um, they are pulled by a force, right? And what you need in order for them to attract each other is opposite ends facing each other, right? And so you have two opposite poles of a magnet, and the opposites attract each other. Well, turns out that it's the same thing for atoms sticking together, that this opposites attract idea works for atoms as well. When atoms form molecules, it's pretty much the same thing as magnets sticking to each other. Don't forget that red slides are where you have to take notes. You should have your notes handout ready to go. Don't forget to look for the owl and let me know where he is. And remember to fill in all of this stuff that you see here. This is something you should know by now. Protons are positive, electrons are negative. But just in case, protons are positive, electrons are negative. 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 Protons are positive and electrons are negative. Protons are positive, electrons are negative. Protons are positive, electrons are negative. Got it? Good. Remember that atoms want to have full outer shells. And in order to do that, most atoms either need to gain some electrons or they need to lose some electrons. So you can see in this little animation here that the element on the left, sodium, is giving an electron to the element on the right, which is chlorine. Now, as previously discussed, electrons are negative and protons are positive. So if the element on the right, chlorine, gets an extra electron, well, it still has 17 protons, and it used to have 17 electrons, but now it's got 18 electrons instead. And so it has one more electron than it has protons, and therefore it has an overall negative charge. Whereas the sodium on the left, is losing an electron. It still has 11 protons, but now it only has 10 electrons, and so it has an overall positive charge. And just like the magnets, that's going to then make them stick together. So, chemical bonding is the attraction that holds atoms close to each other and creates molecules. Molecules like H2O molecules, or like these salt molecules of sodium and chlorine stuck together, or a sugar molecule, or DNA molecules. And those are all just collections of atoms stuck together. And remember, this is very similar to the idea when we talked about static electricity and you were stealing electrons from your hair.
Kinda like this.
Yeah, you remember that. So, when we do this and we create a charged atom, an atom that is no longer neutral, remember, a neutral atom has the same number of protons and electrons. So if an atom gives away an electron or if it takes an electron, it's not neutral anymore. It is now called an ion. An ion is a charged atom. It has either more protons than electrons or more electrons than protons. So that leaves us with two different types of ions that we can have. When an atom takes an electron from another atom, now one of those atoms has more protons, so it's positive, and that's called a cation. It's kind of a happy cat face. And the other one is going to have more electrons than protons, so that is going to be negatively charged, and that is called an anion. Think of like a grumpy onion. Kind of looks like onion, right? Okay. Cation, happy cat. Anion, grumpy onion. There you go. Positive is a cation. Negative is an anion. So take a look at this, see if you can figure this out. Which atom below is the anion and which one is the cation? Okay, well, how do we figure this out? Well, this guy has one valence electron, right? And so what he's going to want to do is give that away to this guy. And so now he's going to accept it. So now this guy has 11 protons, but he has 2 plus 8 is 10. Remember, he gave this one away. So he only has 10. 2 plus 8, and he doesn't have this one anymore. So 2 plus 8 is 10. So he has 11 protons. 11 protons. And he only has 10 electrons. So is he more positive or more negative? Well, he is clearly more positive because he has more protons, right? So what about this guy? Well, he's got 17 protons. Sorry for the bad handwriting. And he's got, let's see, 2 plus 8 is 10. Plus 7 is 17 electrons. That's what he had when he was neutral, but remember, he got one more from over here, so now he's got 18 electrons. 18 electrons. And so clearly he is more negative. So is this guy over here, is he a happy cation? Or is he a grumpy onion? Well, he is the positive cation, right? And this guy is the negative anion. There we go, cation and anion. Which one of these atoms formed a cation and which one formed an anion? So this one lost an electron, this one gained an electron. So this one is going to be more positive, and this one is going to be more negative. So the one on the left is the cation, the one on the right is the anion. Once again, please remember that electrons are negative, protons are positive. Hopefully you got that by now. The atom has a neutral charge when the number is the same. Think about it like this picture here, right? We have 2 positives pulling that way, 2 negatives pulling that way. They cancel each other out, right? This is a neutral atom over here because we have 1, 2, 3 protons and 1, 2, 3 electrons. Those are neutral atoms. When you remove an electron, the atom becomes more positive, right? This guy is neutral, 3 protons and 3 electrons. If we lose an electron, now it's got 1, 2, 3 positive protons and only 2 negative electrons. So it is more positive. When you lose an electron, you become more positive. What is this element, by the way? How can you figure it out? Count the protons, right? It's got 1, 2, 3 protons. What element is that on the periodic table? Let me see. The first one is hydrogen, second one's helium, and the third one down on the first one on the second row is lithium, right? Okay, so when you remove an electron, the atom becomes more positive, or a cation. What are the 2 elements we have talked about that do this? We've talked quite a bit about 2 specific elements that make the stuff that you see on the screen. Sodium and chlorine, right? This is going to be kind of the prime example of 2 elements that are involved in this type of bond, where one electron is donated to another atom. Which one's the cation? Yeah, you got it. This guy's the cation. So when you add an electron to the atom, it becomes more negative, an anion. Will this atom want to lose this valence electron or gain a whole bunch to try to fill up its outer shell? Well, just like a lot of you guys, atoms don't like to do a lot of work, so it would rather just give away that 1 electron. So who's going to want it? Well, somebody that is missing 1 electron, right? So somebody that has only 7 valence electrons and wants that 1 more. Somebody like this guy over here, chlorine. So will this atom want to lose these valence electrons, or will it want to gain 1 more electron to have a full outer shell? Well, gaining 1 sounds a lot easier than losing 7. So he's going to want to gain 1 electron instead of lose the 7. All right, now we need to talk about 3 different types of bonds here. Not those kind of bonds, but chemical bonds. First one is ionic, and the ionic bond really is more or less what we've been talking about the whole time. Electrons are transferred from one atom to another. Generally speaking, this is going to happen when one atom loses an electron, sometimes maybe two, and another atom gains those one or two electrons. The atoms then stick together due to opposite charges. Once one loses an electron, it becomes more positive. The other one gains an electron, it becomes more negative. So opposites attract, just like the two dogs here. A good example of this, one that you want to remember, is sodium chloride, NaCl, or what I like to call NaCl, or what have you have referred to for your whole life as salt. So that James Bond says he likes his martinis ionic, transferred, and not shared. So ionic bonds also form a crystal lattice. If you've ever looked closely at salt, it actually forms these little cube kind of shapes, and that's because of the way the atoms actually stick together. The way the chlorine and the sodium stick together forms these regular repeating cube type of patterns. Now, this process where one atom gives an electron to another one and becomes an ion is called ionization. This is the process of removing electrons from an atom to form ions, and this is why this one is called an ionic bond. All of those words go together. Ion, ionization, and ionic all have to do with this idea of a charged atom. So the reason these guys stick together is because they both become ions. One's negative, one's positive, and you get opposites attracting. So, ionic bonding. Sodium and chlorine. Remember, sodium is in the first column and so has one valence electron. Chlorine is in the second to last column, which has 7 valence electrons. So these guys make a perfect match here. One wants to give away, one wants to receive an electron. Once they do, the sodium becomes positive, chlorine becomes negative, and they stick together. These are what we would call atoms because they are neutral. These are now ions because they are not neutral. And they stick together because opposites attract. Take a look at this little video clip about ionic bonds. All right, there you go. So this is kind of what it looks like. Sodium gives away 1 electron, chlorine receives 1 electron, and they stick together due to the electrostatic attraction. That's just the difference in charges between the two atoms. Our next type of bond is called a covalent bond. This occurs by a sharing of valence electrons. So in this situation, it's not really that one atom receives an electron and one atom gives it away. It's more like they both kind of need some extra electrons, so they share. Okay, and this is a very strong type of bond. This is this kind of bond, a covalent bond. Covalent sounds like cooperate. Yeah, that's what I want you to think of when you think of covalent bonds. Think covalent, cooperate. That's a good way to remember it, like sharing.
Atoms that are 1 or more electrons short of a stable electron arrangement in their outer energy level can also become stable by sharing electrons with other atoms in a process called covalent bonding. The most straightforward example of covalent bonding occurs when 2 hydrogen atoms join. Hydrogen atoms are 1 electron short of filling an outer energy level that holds 2. When 2 hydrogen atoms share their electrons, both become more stable as a result. As the nuclei of 2 hydrogen atoms are identical, neither can completely capture the other's electron. As a result, the electrons spend part of their time in the outer energy level of each hydrogen atom. The result being that each hydrogen atom behaves as if it had 2 electrons in its outer energy level. The negatively charged area created by the overlapping energy levels attracts the positively charged nuclei of each hydrogen atom. Thus, the 2 atoms stay together, not because they are attracted to each other, but because the positively charged nuclei of each hydrogen atom is attracted to the area of negative charge created between them by the shared electrons. The bonds formed as a result of these attractions are called covalent bonds. The units of matter formed by atoms joined through covalent bonds are called molecules. Some of the atoms most common in biological molecules are carbon, hydrogen, oxygen, nitrogen, and sulfur. Atoms of all these elements are one or more electrons short of a stable outer energy level. They obtain stability by sharing one or more pairs of electrons with one or more other atoms. The number of covalent bonds the atoms of each of these elements can form is equivalent to the number of electrons they are short of for a stable outer energy level. A single covalent bond consists of one pair of shared electrons. Hydrogen atoms have only one electron and so can form only one covalent bond with another atom. Oxygen atoms, which are 2 electrons short of 8, can form 2 single covalent bonds with 2 other atoms, or a double bond with 1 other atom. Nitrogen atoms, which are 3 electrons short, can form 3 single bonds, a double and a single bond, or 1 triple covalent bond. While atoms like these can join together in a variety of molecular combinations, none can provide the molecular skeleton required to create the huge, complex molecules essential to life. But fortunately for we living organisms, carbon atoms, which are 4 electrons short of 8 in their outer energy level, can. The ability of carbon atoms to form up to 4 single covalent bonds means that they can create molecular chains that branch off into other chains and form 3-dimensional biological molecules of almost infinite variety and complexity. Thus, carbon atoms form the molecular skeleton of all the large molecules found in living organisms. While these large carbon-based molecules are critical to life, so are other, much smaller molecules. Molecules of H2O.
So, this is kind of what happens in a covalent bond. Now, these are 2, hydrogen atoms. How did I know that? Because they have 1 electron, which means that they probably have 1 proton, and 1 proton means hydrogen. And so what happens here is basically they both share these guys, because remember, they only have 1 electron shell, so they really want to fill that up by having 2 electrons. And so when they do this, think of it like this. They basically have these electrons kind of going around like this. I know it's kind of hard to tell in this animation, but you have the electrons kind of following like a figure 8 pattern like this, where they're going around both of these atoms. And so both of them then feel like they have 2 electrons because they have the 2 going around both of them, and they feel like they're full. And so sharing makes them satisfied. That's a nice story. All right. Atoms that are most commonly involved in covalent bonds: carbon, hydrogen, oxygen, nitrogen, and sulfur. These are what I like to call the CHONS elements, because that's what it spells. Carbon, hydrogen, oxygen, nitrogen, and sulfur spells CHONS. Now, these are particularly important elements here and pretty important bonds, because these are the bonds that form pretty much all living things. You may have heard the term carbon-based life form before. And that is because pretty much all living things on Earth, the atoms, the molecules that make up the living things in their body usually are based around carbon. And that's because of carbon's special ability to bond with a lot of different types of elements. So you can create really, really complex type of molecules like what you see on this screen, which are DNA molecules. And DNA is basically the coding system. This is like the flash drive of life, basically. This is where the information gets stored and then gets brought to the new generation, gets handed down to the new generation. And they use that same information to make them grow their arms and legs and have blue hair, blue eyes and blonde hair and things like that. So this is a really important set of ingredients here. This is basically what you are made out of. Yes, you are made of chons. Okay, last but not least, we have metallic bonds. What type of elements do you think are involved in this? If you said metals, you're right. The bonding between atoms within metals, the sharing of many free electrons. Now, we have talked quite a bit about this idea that that electrons are really responsible for this idea of the properties that we see in elements. Well, in metals, basically you create what we like to call a sea of electrons, and this is responsible for all the properties that we commonly associate with metals. So properties like the fact that it conducts heat very well, which makes it feel cold, but it's not really cold. Remember that, right? So it feels cold because it conducts the heat out of your skin. So the fact that it allows heat to be conducted and electricity, well, that has to do with the fact that all of the electrons are able to move around. Makes sense, right? Electricity is the movement of electrons. So if metals bond in a way that allow the electrons to move around, kind of makes sense that that's why they conduct electricity. It's also the reason why they're malleable, why you can bend them into shapes like the shape of a gun or the shape of a bracelet or something like that. That's why it's able to do that, because of all those loosely held electrons, kind of keeps them together and allows it to not break when you bend it. It also is what makes them shiny. Light reflects off of them in a certain way because of that sea of electrons. So this is all the reason why metals behave the way they do in the world. Think of it like this when you think of it. It's very commonly referred to as a sea of electrons. I also like to think of it like each nucleus of the atom is kind of like a beehive. So these are all like beehives. And the electrons are like swarming bees that all kind of swarm all over the place and go everywhere. And they can move from one atom to another very easily. And so what that means, if you put a strong negative charge on this side and a strong positive charge on this side, because they're able to move around, they're going to get repelled by the negative and attracted to the positive. And basically what I've just described is electricity or a battery or something like that. All right. So that's the idea of chemical bonding. I want to go over one more thing here. I want to think a little bit bigger picture here and take a look at the periodic table and think about who is going to bond with who or whom in these different types of ways. Well, okay, let's think about this. How about ionic bonds? Well, ionic bonds are going to tend to be between elements that have an electron to give away and elements that have an electron that they want to get. So who wants to give away electrons? Well, you should know at this point that the organization of the periodic table is such that all of these guys in this column right here all have one valence electron, thus this number right up here. They have one valence electron that they would really like to give it away. And who wants it? Well, these guys over here that have 7 valence electrons, the halogens, right? So this is why we call the halogens salt formers, because they tend to want to bond with these guys over here and form salts. And when that happens, the alkali metals on the left are going to give an electron to the halogens on the right here, and they're going to tend to form ionic bonds. Who tends to form covalent bonds? Well, remember your chons, right? C, H, I know, H is kind of involved in both of those guys. O, and N, and S. So in other words, kind of mostly like non-metals, right? All the guys kind of over in this area, mostly non-metals, are going to form your covalent bonds, and that's mostly what you are made out of. And of course, metallic bonds are going to be mostly these guys bonding with themselves, right? So you could have, for example, let's say gold bonding with nickel in a metallic bond, okay? And so those are the type of guys that are going to be involved in these three different types of bonds. So generally speaking, we want to think of guys like sodium over here in the alkalis bonding with somebody like chlorine over here in the halogens for an ionic bond. We want to think of these guys here, these non-metals here, bonding together in covalent bonds where they cooperate and share electrons. And we want to think of these guys in the middle, the metals, as being the ones that do the metallic bonds that have kind of the sea of electrons that go all over the place. All right, so we're really getting into some serious chemistry now here. So we have the whole concept. This entire video really is describing how chemistry works. So first of all, chemical bonding is the attraction that holds atoms close together, and this all has to do with ions becoming charged particles, right? Charged atoms. So you have cations, which have a positive charge, and they become positively charged because they lose an electron, and you have anions, which are negatively charged because they gain an electron. And when you get a positively charged cation next to a negatively charged anion, they stick together because of opposites attract. So now we have a few different types of bonds that can happen here. We can have an ionic bond in which electrons are transferred from one atom to another. Atoms stick together due to opposite charges attracting, positive and negative. And a good example of this that you want to remember is NaCl, or really sodium chloride, or really salt. We have covalent bonds, which occurs by a sharing of valence electrons. Remember, covalent, cooperate, and you want to think of the Chans elements for this. And last but not least, we have metallic bonds, which happen between metals, obviously, and creates a sea of freely roaming electrons, which allows the metals to conduct electricity, allows them to conduct heat, allows them to be bent into different shapes, which means they are malleable, and all of that kind of stuff. And one more thing, I would like to thank Connor for his little demonstration of static electricity, stealing some electrons there. Thank you, Connor, and we will go over this quite a bit more in class, and as always, I'll see you then.